Let's continue with the prep review. We're on number 14 now. And it says, determine the, I'm missing a T there for some reason, determine the equation of the line parallel to AB through the point 2, 1. Now, let's remind ourselves we had the line that went through AB had a slope of -4. So we had figured out earlier up here. And if we're going to be parallel to this, the line's going to have this, the new line's going to have the same slope. And if it's supposed to go through 2, 1, it's almost the same line. It's going to be slightly adjusted. Before it went through 2, 2, now it's going through 2, 1, so it's down, moved down 1, you might say. But that would change the y-intercept from 10 to 9 probably. But let's go ahead and figure this out by doing, let's just go to y equals -4x plus a new b. And we're going to put in 2 and 1 to figure out the new y-intercept. So if I put in 2 here, I'm supposed to get 1. Now, -4 times 2 is -8 plus what would make 1? Well, it would have to be 9. Or I add 8 to both sides and I get b has to be 9. So the line parallel will be y equal -4x plus 9 instead of 10 as it was before, and it's moved down 1 unit. Okay? Then it says determine the equation of the line through 1, 2 that's perpendicular to AB. Perpendicular, 90-degree angle. Well, if this line is going down 4 for 1, 4 for 1, or 8 and 2, down 8 for 2, down 4 for 1, this must go up 1 and over 4, and it has a positive slope. So the perpendicular will have a slope of 1/4, as opposed to -4 for 1. So a perpendicular line, you take the reciprocal and opposite. So you change the sign and you flip it over. The reciprocal and change the sign opposite. So the new line will have a slope of 1/4. And the equation would be y equal 1/4 x plus some y-intercept. But it has to go through 1 and 2. So if I put 1 in there, 1 times 1/4 is 1/4 plus something has to make 2. Well, it looks to me like that would have to be 1 3/4 to add up to 2. Or you can subtract 1/4 from 2 and you get 1 3/4. So the equation would be y equals 1/4 x plus 1 3/4. Now, one that's a little trickier. Determine the coordinates, all the points on the y-axis 5 units from B. Well, if I go straight over, it's only 1 unit. If I go straight down, 5 units would take me to here because B was 1, 6. So 5 units that's on the y-axis would have to be someplace here or up there. So let's draw this again a little clearer. So B is at 1, 6. 1, 2, 3, 4, 5, 6. Five units from it would be here or up here, or over here, or over here, but also a bunch of places that would make a circle. If I'm going to be 5 units away from that point, it should be something like that. So there's going to be 2 places on the y-axis. Now, just like we found the distance between from A to B by using the change in x squared and the change in y squared, and then take the square root, if we're going to be 5 away, it's going to be some change in x and some change in y. And if I'm going to be on the y-axis, my change in x is going to be 1 unit over. I'm going to be 1 unit back and down something. I'm not sure how much, or up something, but it's going to be 1 unit. Let's draw kind of the triangle that we're getting here. We're going to get either this triangle or one down here, where this side is 1, and this side I don't know, but I do know that I have to be 5 units from B. So, using the Pythagorean theorem, 1 squared plus what I don't know, question mark, squared has to be 5 squared. So 1 squared is 1, so if I subtract it from 25, I get the question mark squared. The length I don't know has to be 25 minus 1, 24. And if I take the square root to get rid of the square, the question mark has to be, the distance that it has to be, now if I take the square root of both sides, I got to remember to go plus or minus the square root of 24. That's a little bit less than 5. The square root of 25 would be 5, but this is 24. So now to understand these points, I want to give the coordinates of them. So this one's going to have x coordinate of 0 and a y coordinate of 6 minus the square root of 24. And this coordinate would be 0 in the x, because I'm on the y-axis, sideways 0, and I would be up 6 plus the square root of 24. So, the answer to this one, determine the coordinates of all points on the y-axis that are 5 units from B. They would be 0, 6 plus the square root of 24, and the coordinates 0 and 6 minus the square root of 24. And my work is shown here. Okay? Now there's another way to do that one, and I'd like to show you that also. If I'm going to be 5 units from B, I'm going to make a circle. And perhaps you know the equation of a circle. A circle has the equation x squared plus y squared equals r squared. Let's understand that a little bit. If I just draw any circle centered at the origin, every point on the circle would have a coordinate of x and y. X would be how far over, y would be how far up, and there would be a radius for the circle r. So, Pythagorean theorem, this length over is called x, this length up is called y, and the Pythagorean theorem says x squared plus y squared equals r squared. Now, if I move this circle so its center is at 1, 6, we have to remember, how do you move something? Well, if I want to move it plus 1 in the x, you subtract 1 from the x. So the equation of this circle would be x minus 1 squared to move it plus 1. And then to move it up 6, it would be y minus 6. And the radius on this one is supposed to be 5, and so the radius squared would be 25. And there's the equation of all the points on this circle. And if I want to know the ones that are on the y-axis, if I'm on the y-axis, the x-coordinate is 0. So I would put in 0 for x and then solve for the y to find these two coordinates that I already found the other way. So I'd have 0 minus 1, which is negative 1 squared, which is 1, plus y minus 6 squared equals 25. Subtract 1 from both sides, and we get y minus 6 squared equals 24. Now to solve for y, I'm going to have to get rid of the square on this, so I'll take the square root. And once again, I have to go plus or minus, and so it'd be y minus 6 equals plus or minus the square root of 24. Add 6 to both sides, and I get y is 6 plus or minus the square root of 24. And that happened when we let x be 0, and that's how we get the same 2 points. Y is 6 plus the square root of 24, or 6 minus the square root of 24. And x was 0. Okay. Now, something that you may not have excuse me, remember very well from or talked very much about in other classes is symmetry. Now, I've given an equation here that says x squared plus 4y squared equals 8. And I know that it has some symmetry. For example, if I had written the equation y equals x squared, hopefully you would know that's a parabola. And the parabola would look something like this. And it's symmetric with the y-axis. It's the same on the right side of the y-axis as it is on the left. But what about the equation tells me that it's going to be symmetric with the x-axis, or y-axis? And that's that it doesn't care whether x is positive or negative. Whenever you put a positive number in here, like if I put in 2 and squared it, I get 4. If I put in negative 2 and squared it, I still get 4. It doesn't care whether x is positive or negative. So it does the same for positive x's as it does for negative x's. Positive 2 gives me 4. Negative 2 gives me 4. So, because this is squared, it's got to be symmetric with the y-axis. If it was to the 4th power, it would have to be symmetric to the y-axis, because positive and negatives to the 4th always turn out to be positive. Now, if it was y equal x to the 3rd, that isn't symmetric with the y-axis. Hopefully you know that looks something like this, and you can type it into a calculator to check that. Excuse my cough today. Okay? So if x is squared and there's no other x's, this equation is not going to care whether x was a positive number or a negative number. It's going to square it and make it positive. It also doesn't care whether y is positive or negative. So this equation has to be symmetric with the y-axis because x is squared. And it's also symmetric with the x-axis, excuse me, because it doesn't care whether y is positive or negative. It'll give the same result for positive values of y as it does for the same size numbers but negative. So, now there is one other kind of symmetry, and that's symmetry with the origin. Symmetry with the origin means that if there was a point on this side, there'd be a point across from it. Like if 1, 1 was in it, then negative 1 would be in it. Like this one. If 1, 1 is on this curve y equals x cubed, then negative 1 is also straight across from the origin. If 2, 8 is on this equation, which it is, then negative 2, negative 8. Okay, so let's now try to answer some of these questions. Determine all the x-intercepts. Well, to find x-intercepts, you let y equal 0. And if I do that, I get x squared equals 8. Sorry. Taking the square root, I get x is equal to plus or minus the square root of 8. But intercepts are points, so I have to write, okay, it's the square root of 8 when y is 0, and it's negative square root of 8 when y is 0. Now, if I were to graph those two places, the square root of 8, square root of 9 is 3, so square root of 8 is almost 3. So almost 3, 0, and almost negative 3 is 0. There's my x-intercepts. Y-intercepts. When I want to find y-intercepts, I let x equal 0. Because if x is 0, we're on the y-axis. So if I put 0 in for the y, for the x, I get 4y squared equals 8. Divide both sides by 4, and I get y squared equals 2. And take the square root of both sides, and I get y equals plus or minus the square root of 2. That was when x was 0, so I'm going to have the point 0, square root of 2, and the point 0, negative square root of 2. Square root of 2 is about 1.4, so that would be here, 0, 1.4, and 0, negative 1.4. Does it have excess symmetry? Yes. Because x is squared. And yes, x-axis because y is squared. And y-axis symmetry, yes, because x is squared. Does it have origin symmetry? The way you check for origin symmetry is if you change the sign of x will it change the sign of y? Well, in this one, it doesn't matter. You're going to get both plus and minus answers, and so yes, it is. Because if we put in, let's go to here, 3 additional points. Let's put in point 1 for x and see what we get. Now, if I put 1 in for x, I get 1 squared plus 4y squared equals 8. 1 squared is 1. Subtract it from both sides, and I get 4y squared equals 8 minus 1, 7. Divide both sides by 4. And take the square root. Square root of 4 is 2, so that we get that. So when I put in 1, I get square root of 7 divided by 2, or negative square root of 7 divided by 2. Now, what happens if I put in negative 1? Well, if I put negative 1 in here and square it, I'm going to get the same thing. So I'm going to get the square root of 7 over 2 and negative 1 negative square root of 7 over 2. And if you notice that if x was positive, we got a positive here, and if I change the sign here, the opposite of this one also exists. And if I had this point, and if I change the sign to this, this also changes sign. So they're right across from each other. 1 and the square root of 7 divided by 2 is 1 squared 7 divided by 2 is a little over 1. There's that point. And this one is at minus 1 down here, just a little over negative 1. And this one is minus 1 squared root of 7 over 2, and the one right across from it is over here. And so you can see we have this origin symmetry, points across from each other. And so, and if I connect the dots on this, I'm going to get what's called, you might call it an oval. That's layman's term. It's called an ellipse. Yes, because if x changes sign, so does y. Okay, that's all 17 through 23. I'll deal with that equation. 24 is a new problem. This is not related to 17 through 23. This says, determine the equation of a line with no x-intercepts through negative 6, 3. So negative 6, 1, 2, 3, 4, 5, 6, 3, 1, 2, 3, has no x-intercepts. That means it can't touch the x-axis, which means it would have to go like this. So what's the equation of a line that goes like that? Well, just in case you don't know off the top of your head, this point was negative 6, 3. This point would be negative 3, 3. This point would be 0, 3. This point would be 1, 3. There's something about every point on this line. Every point in this line, the y-coordinate is 3. So here's a description of the line. Y-coordinates are always 3. Okay. Now here, as I did earlier here, I talked about a circle, and what if you move the center? Well, here we have the center at -2, 1, and a radius of 6. So to move it -2, it would be x plus 2 squared. X minus the center squared. Plus, to move it 1 up, it would be y minus 1 squared equals the radius squared. And so 6 squared, or 36. So that's the standard form. Now, how do you make this look like this form? Well, we'd have to multiply these out. And I know some of you are going to say this, well, x plus 2 squared is x squared plus 4. And it's not. X plus 2 squared means x plus 2 times x plus 2. Excuse me. And remember that you have to multiply the x times the x times the 2 times the x, 2 times the 2. You have to distribute. And you're going to get x squared plus 2x plus 2x plus 4. And when you multiply this out, you're going to get y squared minus y plus 1 equals 36. Now all we have to do is organize it so that we have the x squared first, the y squared next, that moves this up over here, and then all the number of x's we have, that would be 4x. All the y's we have, that would be minus 2y. B is minus 2. A is 4. And C is the constant. Well, we have 4 and 1, 5. But we also have to subtract 36. So we have 5 minus 36, which is -31, equals 0. This equation is the same as this equation. This is the general form for the circle, and this is the standard form. So finally, what if we have one that's in this form and we want to go back to this form? Well, notice that it was x plus 2, and we got 2x and 2x, and we ended up being 4. So half of 4 was the 2's, which was here. Half of the minus 2 was the minus 1's. The minus 1. So here we have x squared minus 2x. So this must have come from x minus 1. Quantity squared. Because this must have been x squared minus x minus x. But there'd be more. Also, we have this y squared plus 10y. That must have come from y plus 5 squared, because that would be y squared plus 5y plus 5y, just like we were getting here and here for these two. But if I multiply this out, there'd be an additional plus 1. that I don't have here. If I had plus 1, this would factor to this. But I don't want to change my original equation, so I'm going to have to subtract 1. And this would have an additional plus 25. So I have to subtract 25. So I have the x squared and the minus 2x, and the plus 1 would go to making this, and this would be left over. I'd have the y squared plus 10y from this, but I'd get an extra 25 if I multiplied this out, so I have to subtract that. So that's extra. So I have this squared plus this squared minus 1 minus 25 minus 26 equals 10. So if I add 26 to both sides, I get x minus 1 squared plus y plus 5 squared is, adding 26 to both sides, to get 36. This tells me the circle has been moved plus 1, down 5, and has a radius of the square root of 36, which is 6, because it's the radius squared over here, as it said here. So if I wanted to draw a picture of this, the center's at 1, negative 5. So if that's 1, negative 5, negative 4, negative 3, negative 2, negative 1, 0, I'm putting my x-axis here, my y-axis here. So this point is at 1, negative 5. And I have to have a radius of 6. 1, 2, 3, 4, 5, 6. It would go through here, through there. 1, 2, 3, 4, 5, 6 through there. 1, 2, 3, 4, 5 through there. This is the x-axis. This is the y-axis. And I'm supposed to make a circle that goes through those places. $30.